Simplistically, integration is the reverse process to differentiation, and indeed in many of the WACE courses it's referred to as anti-differentiation, a term I don't really like because historically that's not really borne out. Integration and differentiation didn't come historically in that order. So if y is equal to x cubed, then we know by now that dy dx is 3x squared. So it would follow that if integration is the reverse process, and this is how you write an integration, you have this integral symbol and the dx, and those act as a pair of brackets, and the thing that you're integrating goes in the middle here. It's called the integrand. And if you integrate 3x squared, if it's a reverse process, you'd expect to get x cubed back. But you should note that if you have x cubed plus any constant, doesn't matter what the constant is, 2, a million, you know when you differentiate it, that constant will disappear. So x cubed plus any constant gives you 3x squared. So what we do is we write this plus c when we do the reverse process, which tells us that there could have been any constant there when we originally differentiated. In general, the formula is this. If you integrate ax to the n, you get ax to the n plus 1 divided by n plus 1 plus a constant. And that works provided n is not equal to -1. If n is -1, at this stage you won't be able to do it. That comes in a later course. So the way I always remember this, though, rather than trying to remember this complicated looking formula, is that I increase the power by 1, goes from n to n plus 1, and then I divide by my new power. And that's the way to remember it. So we've got a couple to do in this example. One of them is fairly complex and the other one's pretty simple. So this one's a complicated one, this one's fairly simple. So with the 6x squared, I know that the 6 is not going to actively integrate. The power is going to go from 2 to 3, and I divide by the new power. And then I just add c, and then I tidy up. So these cancel down, and I get 2x cubed plus a constant. This one, what we're going to have to do is actually sort out the indices here. So there's a bit of work to do before we can integrate. So I'm going to write that as 2x over root x, which is, of course, x to the half. Take away 1 over x to the half. So I've written the root x as x to the half and split the fraction up. Now we know when we're dividing, we subtract indices. So this one would give me 2x, remember this is x to the 1, so 2x to the half if I subtract the indices. And remember this 1 on top here is x to the 0. So if I subtract 0, take away a half, that's x to the negative a half. You might have remembered that an x to the half on the bottom is x to the negative a half as well. Okay, so for the first one, I've got 2x, increase the power by 1, and a half add 1 is 3 over 2. And here we're going to have x to the half because we add 1. Now remember, we need to divide by the new power. So here dividing by 3 over 2, here dividing by a half, and don't forget the constant. Now, if you're dividing by 3 over 2, that's the same as multiplying by 2/3, isn't it? When we divide by a fraction, we turn it upside down and multiply. So if we're multiplying by 2/3, so let's just do it over here rather than messing up the working over here. I've got 2x to the 3 over 2, and I'm timesing by 2/3, so that's going to give me 4x to the 3 over 2 divided by 3. With this one, turn it upside down, and then I'm multiplying by 2 over 1.